Welcome to today's webcast series presentation, OpenRoads Designer, Solving Civil Design Critical Business Issues. My name is Bob Drake, editor of Civil and Structural Engineer magazine, published by Zweig Group. Thank you for joining this webcast, which is sponsored by Bentley Systems Incorporated. Before we begin today's presentation, first some general information about the webcast and the GoToWebcast platform. The views of the speakers and organizations participating in this webcast are their own and do not necessarily reflect those of Civil and Structural Engineer or its publisher, Zweig Group. If you have any technical difficulties while viewing this webcast, please submit questions or a brief explanation of your technical problem using the Ask a Question box on the left side of the webcast dashboard, and a representative will assist you. Note the button in the upper right corner to enlarge the slide viewing window if desired. During the webcast, you also can submit questions to our speakers using the same Ask a Question box. Submit your questions at any time, and we will try to answer as many as possible later in the webcast. Zweig Group encourages group learning for our events. If you are viewing the live webcast with a group on one registered person's computer, that person must complete and submit the multiple viewer registration form for the group in order for everyone to earn credit. Download the multiple viewer registration form from the event resources on the left side of the webcast dashboard. Submission instructions are on the form. Also note a link in the event resources section to download a PDF of the slides in today's webcast. Details on downloading a certificate of completion will be provided later in the webcast. Viewers of archived webcasts must pass a quiz in order to download a certificate of completion. Additionally, at the end of today's event, we will provide a webcast evaluation survey for you to submit your feedback. Today's presenters are Mo Harmon, Solutions Executive, Road and Bridge with Bentley Systems, and Joey Llewellyn, Application Engineer with Bentley Systems. The learning objectives for the event are shown for your review. Details on downloading the certificate of completion will be provided later in the webcast. And as I mentioned before, viewers of archived webcasts must pass a quiz in order to download a certificate of completion. So let's get started. Mo, I'll hand it over to you.
Thanks, Bob. Well, first off, thank you all for joining us today to learn a bit more about the upcoming release of OpenRoads Designer. OpenRoads Designer is basically taking the best concept of our legacy products, En-ROADS, Geopack, MX, and combining them with the latest innovations to create our next generation and detailed roadway solution. We'll take a look at the benefit of designing with reality context, rapidly modeling our design intent, integrating multiple disciplines, adapting to change, improving project deliverables, and easily visualizing our designs. Today, many of your organizations have to procure, deploy, and train multiple Bentley offerings to meet deliverable requirements. As you see in this graphic, OpenRoads Designer will be a single license, a single installation, a single solution that will simplify your process. OpenRoads Designer, above and beyond the premium civil products that I just mentioned, will also include Descartes capabilities, the new Ghent civil tools, SU, SUDA, as well as MicroStation. Joey will get in a lot more detail. We mentioned the critical business issues in the description. So he'll get into those and highlight those, but I want to kind of discuss a few of those and how they support industry direction. The first one we're going to talk about is design with reality context. You see there big data, expanding data types, innovation drives change. The availability of data, the expansion of types of data, and one of the bigger ones is actually the ability of software and hardware to consume that data is really changing the process. And that last bullet, innovation drives change, you know, one of the key things I thought about is it is broke, let's fix it. I know all of you probably do have some clients that are slow to change, but the industry is changing, and this innovation, the design with reality context, is having a huge impact. Rapidly model design intent This one is absolutely a necessity. A lot of people are concerned that there's a perceived impact to cost schedule associated with 3D project delivery. Again, Joey's going to get into a lot of the detail of this, but this one again is an absolute necessity. Integrating multiple disciplines. We've already talked about reality data, SUDA, the GINT civil tools, but Bentley's common modeling environment will also allow the integration with things like bridge data using OpenBridge Modeler, rail, as well as buildings. So this is going to ultimately improve the collaboration, not only within an organization, but with subs, owners, etc. It'll also reduce risk, find early conflicts. All of this will ultimately benefit the integration to the project because of that integration. Adapt to change. It's, to me, is an extension of that rapidly modeling design intent. But the big thing here is that it offers the ability to make changes without circling back to the beginning. So you're not having to redo work. You have to be able to adopt a change quickly. Another big critical business issue is improve project deliverables. So regardless of whether you're working on a traditional design bid build project or alternative delivery projects, such as design build, CMGC, P3, etc., the deliverables, or rather the data, this is beginning to shift from what we consider 2D plan deliverables to being focused on the data. That will be critical to the delivery and the success of the project. We know that plans will still be required, but we do have some organizations that have it in their vision as early as 2020 to receive no 2D drawings. And finally, Visualise Designs. We need to be able to do that easily, quickly, and it needs to be the actual design visualized in real time. The industry, the cost to do some of these visualizations and why they're being done, right now the focus is more around collaboration, understanding the problem, and again, we believe that that's a critical business issue. To kind of put this, why are we focused on these things? Well, the industry is going digital. There's no question. There's a lot of effort going on to do this. And to reach that goal of what in North America we pretty much call SIM, is all of these critical business issues have to be addressed to remove the losses. You see in this diagram on the bottom, the red one, there's losses that occur across the different phases. So in order to reduce those losses, we have to address those critical business issues as well as improve the efficiencies even within our own discipline. So in an organization working between, say your roadway group and your drainage group and your structural group, we have to improve that process, not just across phases, but again, across disciplines. Now, I've just kind of covered those things at a very high level, looking at these are some of the critical business issues that we're focused on. But again, it's all related to the industry, why we're doing it, why it's important to us, because it is happening. Now I'm going to turn it over to Joey. Joey's going to dive a lot deeper into these critical business issues, and you'll kind of see with the OpenRoads Designer what Bentley's done to move that forward. So, Joey, I'm going to turn it over to you.
All right, thank you, Mo, and thank you all again for joining in. As Mo said, I'm going to cover a little more of the technical side related to the business issues which he's discussed previously. So we want to first talk about designing with reality context. And reality context, if we look at that in a broad sense, it really includes a lot of the things we've done in the past. It includes our terrain model of our existing conditions, aerial imagery, GIS data, point clouds, and even reality meshes. So OpenRoads Designer is built to be able to consume data, existing data from multiple sources so that you can access it, so that you can consume it, so that you can utilize it when it comes to designing. You'll notice within OpenRoads Designer in the top left, we have a menu which we term the workflows. So the breadth and of functionality with an OpenRoads Designer is quite large in order to be able to provide, again, a series of workflows so that you can work on a project from beginning to end. Now we're focusing again on the reality modeling side of things, and we want to look at how, just some basic examples of how OpenRoads Designer lets us consume data. As a project's beginning, we have to have context of what's actually there. You can see the terrain model on the screen of the interchange where our project is going on. And so we can see that in the 2D view on the left, the 3D view on the right. As Mo mentioned, OpenRoads Designer and really the industry at large has noted key benefits in working in 3 dimensions. Now we've got 2 separate views. In the left-hand view, we're going to turn on aerial imagery. And all of this, again, is within OpenRoads Designer, and we're sort of building the foundation of our project. We see the terrain model. We've added in aerial imagery as well for a little more context, a little more definition. So we've got aerial imagery in the 2D plane again. Notice our 3D model simply shows the terrain model. So we're separating the 2-dimensional data from the 3-dimensional data. And in one sense, that's extremely useful and extremely powerful so that you can understand the data easily, so that you can look at the data in 2 dimensions or 3 dimensions in different ways. Now we'll continue adding data. We're going to just reference in a shape file so we can see the property lines, the right-of-way, and the boundaries related to this interchange as well. So many of you probably have experienced this quite a bit. As you begin a project, you're always on the lookout for data, whether that's property lines or terrain data or imagery, whether that's in the form of shape files or some other data type. Again, OpenRoads Designer allows you to consume lots and lots of data from lots and lots of sources so that we can put that data together in context to get a good picture of the existing conditions. So we've added in the imagery, we see the terrain model on the screen, and we've actually referenced in a shape file of the property within that area. Now we're going to continue on and we're going to begin to add in more along the lines of thinking 3D. So we're going to add in a point cloud file. So we'll just grab those. There's the point cloud tool set is directly in OpenRoads Designer. And the functionality for advanced tool sets, such as draping line strings and things like that, is included as well. Notice on the right-hand side, we have a representation of the point cloud that's different than on the 2D view. So in the 3D model view, again, we can separate the data and get different perspectives of the same data so that we can understand it better. Now we can just modify the views independently of one another so that we can change the perspective a little bit so that we can understand it. So we've got that LiDAR file. Point cloud is now attached. As I said, we can modify the views independently, so we turn off view 1, but we remain, or we let the point cloud remain in view 2. Now, in addition to just attaching a point cloud, there are presentation styles. So based off of that point cloud, we can modify, again, how it's displayed. Right now, we're displaying that point cloud based off of an elevation range. And you'll see here, I'm just making a modification of the data, and you'll see that change in the right-hand view as I modify the elevation difference that I want to see and the colors as well. So we've taken that point cloud, brought it into OpenRoads Designer, and now again we have the ability to sort of analyze it and begin to understand maybe where the high points and the low points are. Okay? And all that data again is being consumed and put together so that we can understand it. Okay? So we've got imagery, we've got the terrain model, we've added in shape files, and now we are looking at the point cloud as well, and we can see that in the 3D view. We'll zoom out, fit the view just a little bit. Now we're going to go and add a little bit farther, we're going to add a reality mesh. The reality mesh is output from context capture. If you're not familiar with context capture, that's another product from Bentley where you can take imagery, either imagery from overhead from an aerial, imagery taken from your cell phone, if you want to take shots or pictures of a head wall or something like that. Then context capture processes those and creates a reality mesh, which we are attaching here. Reality mesh is a .3mx file. So we just add that in again with all the additional data. We reference that reality mesh in, and now in both views we see the results. On the right-hand view, you can see the trees, you can see the fields and the earthwork or the earth around it, and we can just rotate that view and really get a very robust, a very dynamic, I guess, representation of reality at our project site. And that again is reality mesh. The key thing here is being able to consume and associate all of this data together effectively, and not have to spend time manipulating, searching, and converting and translating data in order to get it all together. So next, when it comes to critical business issues, as Mo mentioned, being able to rapidly model our design intent really is key. Now, there is a perception that modeling, and I'm putting that in air quotes, requires a lot of extra effort and a lot of extra work and steps. OpenRoads Designer is built to model as you design. So in OpenRoads Designer, as we model, as we design, they're really one and the same, okay? And we're going to take a look at some examples here where design intent is included across all of OpenRoads, including alignments, corridors, intersection, drainage networks as well, and civil cells. And we'll take a look at those in just a second. But again, the key thing, I think, to understand is to recognize that within OpenRoads Designer, and really it's a transition maybe of the industry itself, modeling is not a post-process. Designing and modeling are the same thing. So in OpenRoads Designer, the intention is to model while you design or design while you model. They are really one and the same, okay? So let's take a look. So here we have our terrain model. We're in the same area as before, and we're just going to quickly model a 4-lane divided highway. So on the right-hand side, or the left-hand side, excuse me, you can see the existing roadway, and we're going to create a 4-lane divided model, corridor over the top of that. And we want to be able to do that quickly. We want to be able to see it. We want to be able to evaluate it and analyze it so that we can make engineering decisions as we create, as we design. So here I'm just quickly, again, sort of getting a quick centerline representation along the existing roadway. And you'll notice I'm laying out the horizontal, but I'm going to produce the model at the same time. So I'm taking advantage of some of the OpenRoads settings and feature definitions where I actually create the horizontal, the vertical, and the roadway corridor simultaneously. And now over in the 2D or the 3D view on the right, we're able to see the representation of the model. Now, we're not finished. That model is live and dynamic. So as an engineer, I have the ability to make modifications. Here you see me modifying the start station a little bit. I just graphically move the location of the horizontal alignment and the corridor updates. The same for the horizontal curve. If I needed to modify that curve, here I just graphically moved it, but you can see the representation of the model changing with it as well. So again, as an engineer, as a designer, I want to be able to see the results of my design quickly so that I can analyze it and evaluate it. And that's what we're looking at here. So I've turned off the triangles in the right-hand view. And again, I want to be able to just clearly display those in multiple ways so that I can analyze and make my engineering decisions. Okay? Now, if we zoom in on the model on the right, you'll notice that there are guardrail, there is a cable barrier present in the model. So this is a very robust model. There are a lot of details included here. I want you to notice, too, that the model, the pavement buildup of the model actually is comprised of components. Each of those pavement layers represent the constructible and quantifiable components of that corridor, okay? Now, again, interpretation and decision making is what we do as engineers and designers. So I'm able, again, to dynamically and interactively work between the views to interpret and design and modify. Okay? So we want to be able to convey our design intent within the model. So I'm going to make a modification here. I don't like that steep slope, and I'll do that in just a second, but you'll notice the steep slope along the left-hand side of the roadway. And I've opened up the cross-section view, and I want you to be able to notice that, again, the cross-section view allows me to make decisions, to interpret that roadway corridor. I can see the barrier, the cable barrier, as well as the guardrail. Even the existing right-of-way is displayed in that cross-section. Okay, so I'm able to see that, and I'm able to make decisions from it. Now, again, in looking at that, I want to make some modifications, which we'll see later. Now, one of the key advancements within OpenRoads technology and OpenRoads Designer is using civil cells. Now here, I'm going to place an entrance or a driveway. And so I'm using a civil cell, and I'm using that civil cell based off the references in my model, and I'm going to place that driveway entrance. So here, we're able to place this quickly. We're able to take that civil cell, which a civil cell is really a pre-configured design element that carries and maintains your design intent. So you see that now, you see that entrance being placed over in the 2D view on the left as well as on the right. And so it is now in the model, as we would say. So now we have that entrance associated with the corridor that we created previously, all within a single design model. Now, to take this just a step farther, we're going to include, when it comes to modeling and designing, especially carrying our design intent, Mo mentioned this, no project exists by itself. So OpenRoads Designer has tools included for the subsurface utilities and drainage analysis tool set. So I'm going to take that same corridor and I'm going to place a drainage inlet. And you can see that on the screen. And the right-hand side in 3D now, we can see that inlet being placed in the bottom of the depressed median. And now I'm going to pan over to the north side and I'm going to place the outfall structure. So once again, I'm just using the subsurface utilities within OpenRoads Designer. And I'm going to pick the proper head wall. It's got a 3-to-1 slope on that fill slope. And then I'm going to move over. Now I'm interacting with the roadway corridor. So when we talk about multidiscipline modeling, we're talking about being able to utilize data from other disciplines. We're also talking about those disciplines such as drainage using our roadway corridor. So our drainage structures are relative to our roadway surface, right? So now so they're working together. We have the inlet placed and we have the outfall placed. And now I'm going to just connect them together with a concrete pipe. And again, I'm laying things out in 2D. We see the results in 3D. So I'll connect those up, and now we can see those elements within our model. Okay, and now this leads us really into our next topic, multidiscipline integration, being able to integrate model data or design data from multiple disciplines. In this case, we placed drainage structures relative to our roadway design. And again, that data is not only just integrated with it, it's interacting with it. So let's take a look at integrating multiple disciplines in OpenRoads Designer. And we'll take a look at several examples. We'll take a look at geotechnical data, bridge model data from OpenBridge Modeler, as well as drainage. This could include buildings and other structures as well. Again, if we're making design decisions within a modeling environment, and it's important here too to point out that OpenRoads Designer really is a common modeling environment so that we are able to exchange data and we're able to access and utilize that data when we make design decisions. And that's really the basis behind integrating multiple disciplines. So let's take a look. Here we are. We have just another example. We have the interchange here within the area that we've been working. You can again see the terrain model. You see the roadways, the proposed roadway changes. And again, we can rotate that up, take a look at it. You'll notice a couple of things. Now, within this project, there are multiple keys or disciplines that we need to evaluate. And the first of those might be geotechnical data. OpenRoads Designer contains a tool set, geotechnical tool set, where called Ghent Civil Tools. You can access Ghent data and bring it into a DGN in 3 dimensions if you want. I'm going to just reference in some Ghent bore log data here into my design model. And now notice everything is geospatially located. So when we begin to bring Ghent data in, it's geospatially located. It's located correctly in the elevation, so the elevations of all those logs are correct based off the material that it is. You'll notice that you can select those bands, and you notice that the material's carried along with it. So rather than bore log information being on a series of paper sheets or PDF files in someone's desk drawer, we want to make that data accessible and useful directly within the model. Again, it's really a comprehensive modeling environment so that we have that ability to get a full picture of our project area and the engineering data that we need to evaluate going into it, okay? So again, geotechnical data, we can bring that in. We also can access 3-dimensional bridge data from OpenBridge Modeler. And so now I'm just going to select an OpenBridge Modeler bridge model and reference that into my project as well. And so you see the bridge being placed in the model. You can see that now. Now at this point we have the existing terrain displayed, we have the proposed roadways, we have the geotechnical data, and we have a proposed bridge for the overpass, all displayed within a comprehensive, contextually correct model so that our decision making can be much better. All right, so we see that model, and then of course we see a clear error here that we may have missed otherwise, that pier location happens to be conflicting with our roadway there. And so simply by putting those models together, we're able to see those issues earlier on in the process and hopefully catch them and make changes. Now finally, we have at this point, again, we've displayed the geotechnical data, we've displayed the bridge model within the interchange, and we've already seen a little bit of this, but I'm going to go ahead and pan down to another area of the project, and I'm going to just turn on and reference in a drainage model. Now, the point here really is to know that the data between disciplines doesn't have to live in one file. So the drainage designer, the drainage engineer, could have used my roadway corridor, my drawing file, to create their storm drainage model, and I'm going to reference it back to my roadway model now. So again, we begin to collaborate back and forth so that we can view each other's work and make sure that we are working together so that our drainage structures aren't, the elevations aren't incorrect, and so forth. So this drainage model was created by the drainage engineer, and I'm simply referencing it into my roadway corridor, again, to add a little more context so that I can evaluate and that we can be clear that our designs coincide and don't conflict with one another. And so there you see the drainage network going down the center line of the divided highway. Now I can rotate that view. I can modify the display properties of that view if I want. So if we want to see the drainage network more clearly, I'll just turn off the corridor graphics, and now we see just the drainage network itself displayed. Okay? All right, so that's integrating multiple disciplines. Now let's take a look at really how all of these things, how they work together. OpenRoads Designer is really model-centric in the way we do things. When it comes to project deliverables, including our plan sets, which we're going to take a look at, they really are dynamic, model-based plan production tools. Okay? So if the model changes, the resulting plans change as well. In the OpenRoads modeling environment, again, there's several points that you see this throughout the product. One is, again, being able to model and interpret the model in multiple views, in multiple representations, whether you want to look at that model in a cross-section view or a profile view, or you want to rotate it to the front view or the side view or the bottom view, whether or not you want to clip at any point throughout the model. All of that is available to you because of the common modeling and the comprehensive modeling tool set within OpenRoads Designer. Now, that being said, as we look at project deliverables, we're going to focus on the plan production tools within OpenRoads Designer. But again, they are model-based and model-centric. So let's take a look, first of all, at creating plan and profile sheets. Now, within the same project and the same data set, we are going to basically define plan views along our corridor, and you can see those on the screen. So, working with the OpenRoads plan production tools, I've defined the plan views along the plan, or along the corridor, along the alignment, with a width and a length and so forth. Now I'm going to define profile views within the profile along that same project, along that same corridor. Now all of this data works together, okay? So we're going to change the plan, the name of this particular group, but it's all based off of the plan views we created previously. Now within the profile view, and again this is a dynamic view of the vertical, I place those views, and now here I want to make a note. As I create drawings, make a note of the sheet index. And from those settings, which are, again, standardized settings that we've created for producing these sheets, we now can see all of the plan and profile sheets created. Notice the sheet index on the left. We have access to all of these sheets, as well as the individual clipped sheet models from the design model as well. So we can move through the sheet index and move from sheet to sheet, drawing to drawing as needed. Again, we also have access to the individual sheet models, which you see there. Okay? Now that's plan and profiles. For cross-sections, it's a similar workflow. We place boundaries along the roadway, along the alignment or the corridor, and we'll define the offsets left and right. We'll define station limits and vertical exaggeration and so forth. Okay? Now, as we'll quickly work through this dialog box, we'll just begin defining a start station and a stop station for this set of cross-sections we are going to create. Okay? Now, as we data point, the create drawing opens up, and notice we're adding these cross-section sheets to the index as well. Different sheets, different drawing files, but they're added to the same sheet index. So those will process, and now we can take a look at those cross-section sheets that were created from that roadway corridor model. Okay? Again, the basic premise is we have the model designed and created. We create views. Those views will then be put into sheets that we see now, and you can see the results on the screen. So those cross-sections from the model are all placed, and the annotation is placed based off of our standards that we incorporated when we created the drawing. And we can go back and now look at the clipped sheet view, the sheet model that holds the data as well. And so we can look across and see cross slopes, elevations, and so forth. Now, in the sheet index, I mentioned before, notice that we are able to move, although we created them in separate instances and separate files, because they're added to a common sheet index, we're able to access the cross-sections and those plan and profiles in one place. So I'm able to move between the model file, the design model, which you now see on the screen, and the individual sheets, whether it's plan and profile or cross-sections, in one location. Now, from that sheet index as well, I'm able to plot. So I can selectively pick whichever sheets I'd like to plot. Here we're just selecting several of the sheets. We're just going to highlight those and then send those out, plot those as PDF files. Click OK there, and then here we've opened up the PDF file, the resulting PDF file from plotting those individual sheets. So in terms of project deliverables, I've focused here on plan production because I want to make this point. Plan production is still relevant, and the tools provided by OpenRoads Designer, again, give us really the opportunity to give us a tool set that's model-based, it's dynamic, and we'll see that in just a minute. So when it comes to adapting to changes as we design in the model, being able to see those changes reflected in our plan sheets is extremely important, okay? But again, the model becomes the heart, the foundation of everything where we design, where we build our sheets from, and so forth, okay? All right, adapt to change. I'm certain, I know we all have to adapt to change. So this is a key component or a key element when it comes to especially thinking about critical business issues. Being able to handle change effectively and efficiently is extremely important. So what we're going to do is take a look at OpenRoads Designer. And we've already seen some basic changes where we modified the alignment a little bit, and we made some slight modifications to the start station on our corridor. We also looked at where we moved the radius around a little bit, and so we saw the results from that as well. Now, here I highlighted several bullet points. The alignment changing, well, that's one element that could change within any given design. Safety measures as well. We'll see how we can make modifications in our design if we need to change from a guardrail maybe to a cable barrier and so forth. Design changes. There are always design changes, and those could be changing a side slope for safety reasons. It could be modifying, again, the vertical alignment to get clearance in a certain area that we need. It could be modifying the depth of the pavement. And all those things happen all the time. And we want to be able to handle those effectively and have those changes effectively propagate throughout the design and throughout our deliverables. And that's really at the heart of OpenRoads Designer and what our intention is. So we'll look at design changes. Again, I'll give you some examples, and we'll look at construction document changes that result from the design model changes. So let's take a look. All right, I'll give a little clarification before we get started. We are looking here again at our corridor we created earlier on, and we can see the 2D view on the left. The upper right is the three-dimensional model view, and then we have the cross-section view in the lower right corner. Now, we're going to make some design decisions in this situation. Again, I think it's extremely beneficial to be able to evaluate the data live. So maybe, for example, we need to modify that cable barrier and change it to a guardrail. So I'm just simply browsing. I'm going to select that three-dimensional feature in the model and change from a cable barrier to a guardrail. Now notice the change. The change has been propagated in the model and into the dynamic sections. So that's one type of change, and it's a direct change into the model, and we see that propagated out. Now, a design change, in this case, that we might want to make, you notice that side slope's quite steep, but I still have quite a bit of right-of-way out to the north side of the corridor. So I'm going to modify that slope. I'm going to flatten it down, and I'm going to tie it to existing right-of-way, and I'm going to use something called target aliasing. Target aliasing is extremely powerful. It allows you to basically take an end condition within your roadway model and you can associate it to anything, 2D, 3D. Now, I'm going to graphically select the element that I want my end condition to tie to. Now, I'm graphically picking the right-of-way line in the 2D view. So I'll pick that right-of-way line, click Apply, and then we'll see that side slope modification. We see it in the 3D model, we see it in plan view, and we see it in the cross-section. The side slope changed, and notice that the guardrail has been removed as well. So when it comes to modeling with design intent is at the heart of everything within OpenRoads Designer. So that changes, that when we make a change, it's not just a static change in a silo. We recognize how things are put together, how you've built each and every element, so that when you make a change, we maintain that intent that you imparted to that design. So again, this is just one example of adapting to change in a design modification. Let's take it a step farther now and look at what that means for our planned production. So in this case, I'd already created cross-sections of that particular area. We can see those cross-sections on the screen, and I'm going to just browse now into the clipped view. You'll notice that the slope has changed. Rather than being a one-to-one slope, it's tying down to the right-of-way line, just as I modeled it in the design model. And now what I'm going to do is just update the annotation within the cross-section. Now I'm just simply, again, I just simply removed and refreshed the annotation within that cross-section set. And now back into the sheets, you can see that the annotation has updated as well. We had a flatter slope and we had the annotation placed. Now, just for a second, let's take this all a bit farther, okay? We've looked at what happens in a cross-section sheet when I dynamically modify the model. Those changes were propagated into that sheet. I refreshed or updated the annotation based off the model changes, and we saw that in the cross-sections. Now, when it comes to adapting to change, there's a multitude of changes I could have given examples for. We could have spent the entire session on adapting to various types of changes. In this case, in the upcoming example, we're going to look at profile changes, the vertical alignment changes, and really at several of the big impacts a vertical alignment change might have downstream on your deliverables as well as your design. All right, so we're turning our attention to the profile view of things. And make a note here, the profile grade on this particular profile is 1.8%. And what we're going to do, we're going to make a modification to that. And again, see how OpenRoads Designer handles that. So now, we're going to first of all place some annotation. Again, we want to see the impact of model changes propagated throughout our design process. So here we're just placing a simple one-spot annotation along our vertical alignment. And so we're just going to place station and elevation at that given point. Now what happens to that when we modify that vertical alignment? Now we've switched back to the design model. Okay, there's the design model where we model, design, and engineer what we want to build. And now we've made the modification. We've changed that grade from 1.8% to 3%. And now let's go back and look at that view. Notice the elevations for cut and fill have been updated. The slope is now 3%, and the station and elevation of our known point or our design point has been changed as well. Now, that's one aspect. So the annotation of that profile has been modified and has changed. When we made the design modification of the profile, the annotation followed. What about the sheets? What about the predefined sheets that I had already created based off of option 1 of my profile? And that's what we're going to look at right now. How do I recreate or reclip, reassign now that I have such a steep grade along this profile when it comes to building sheets? Now, what we're going to do is we're going to open up named boundaries. And basically what we're going to do, again, to simplify this, is we're going to take that current profile view, our modified view, we're going to recreate the clipped views along it and append them, really replace and append them to the existing cross-section or profile view group. All right? So we set up the dialog box. We'll data point in the profile view and notice how those profile views have reassociated to the new vertical, maintaining our design intent, maintaining our standards so that we have a minimum clearance along the top of the view and the bottom of the view. We have a set spacing from the existing ground to the bottom and so forth. So again, even with the design change as drastic as modifying that from 1.8 to 3%, which in some sense may have wreaked havoc in some of our downstream processes, we're able, from a model-centric environment, to come back. Again, Mo mentioned not having to redo things in a linear process. In today's world, working in a linear process from 1, 2, 3, 4, 5, and if something changes at 5, we don't want to go back to 1 and start again. We want to be able to go, something changes at 5, we want to be able to make the change and have everything else come along with us. Okay? So that's what we're doing here. Okay, so again, based off that vertical change, we looked at the annotation follows along, and then we looked at just appending and recalculating and redefining the sheet boundaries as well. All right, so we have looked at, just to kind of catch us up here a little bit, we've looked at several of our business issues. We've looked at integrating multiple disciplines. We looked at rapidly modeling design intent. We've looked at modeling within an existing context. And we've looked at improving project deliverables. And now we want to look at visualizing designs. Visualizing designs could be considered a project deliverable. Okay? The couple of points that I just want to highlight here as we discuss this and as I show you a couple of things. Number one, consider visualization as visualizing the design model, not creating a separate model that you need to recreate and rework for visualization. Visualization is a byproduct of the model you're designing. Okay? So the design model is the basis of visualization, just as it is the basis of plan production. Just as it is the basis for digital construction data that we pass off to a contractor for machine guides. Okay? The other point I want to make is that visualization is important, not, and you may have heard me say this, I say it several times, it's not necessarily a tool for communication, it's a tool to convey understanding. Visualization is a way so that others can understand what your project entails, so that they understand what the right-of-way, what the culvert's going to look like, what the new driveway or the wide roadway is going to look like at their house. And it's a little bit of a subtle difference, but think about visualization that way. Now, when it comes, again, looking at OpenRoads Designer, we'll look at some examples. We have our interchange here. OpenRoads Designer includes visualization tools. Now, those tools are really the visualization tools that you would have found in MicroStation previously. So tools to animate cars, tools to place three-dimensional elements, tools to control lighting, and so forth. Those are all available in OpenRoads Designer. And let's take a look. So on our Workflows menu, again, from that Workflows menu, you can see the breadth or the width of functionality in OpenRoads Designer. You'll notice across the top that tab. In this case, we're going to export to Lumen RT. Lumen RT really is a very direct and pretty straightforward application for creating visualization and animation. And again, don't think about creating a separate model. Your design model gets pushed out and exported to Lumen RT. Lumen RT contains functionality for placing trees, different types of materials, traffic, such as you see here on the screen, all of those types of tools to really bring your design to life and really convey understanding to the constituents that are interested in it. That's what Lumen RT is for. So take your design model. Again, we can place traffic and modify lanes. You can animate individuals, cars at particular locations if you want to highlight an intersection. And here you'll see, again, an off-ramp with a truck driving around it. And so when you think about Lumen RT and you think about what can be gained by visualizing your design model, again, think about taking advantage of it. OpenRoads Designer really is built and intended so that, you know, all of these needs can be met. Now, Lumen RT here we're going to show 3D line style support, meaning that line style, that 3D line style in MicroStation for a barrel or a guardrail or a fence or cones or anything else can be carried into Lumen RT. Lumen RT also has output for virtual reality. You can see that here on the screen as well. And here's just a flyover animation of a large project in Mobile, Alabama. And there we can see that as well. Okay? Now, Lumen RT, so that is Lumen RT. And now, one last point before I wrap up, and I would be remiss if I didn't mention this. In OpenRoads Designer, sometimes finding information may be a little difficult. Sometimes searching for information, answers to questions may be difficult. OpenRoads Designer contains what we call ConnectAdvisor. ConnectAdvisor is really a search engine that searches across the Bentley communities, the Bentley Learn server, and Bentley's YouTube channel. And you can see those there on the screen. And so from the product, directly from OpenRoads Designer, you can open up ConnectAdvisor, as I've done here. You can search on specific topics. Here I'm just going to simply search OpenRoads Designer. And we'll see the content that's available to us from all of those sources. Again, Bentley Communities. We can see posts on the Bentley Communities Forum or the Wiki page. We see Learn server content, so we see on-demand classes that are available to us from that. And the beauty of it is it's all in product. No need to have multiple favorites in Outlook or in Internet Explorer. We want to make that easy to find. So now I've searched on the Learn server, and you'll notice there's several classes available for OpenRoads Designer already. Now, this to me is extremely useful. I don't just see that there's a class available, I can access it. I access it directly from the ConnectAdvisor in the product. So I click on it, I'll notice the on-demand videos that are present on the right-hand side, and I can access those videos, again, directly in the product. So I'll just click on that, and then it opens up that on-demand session related to that topic within the overall class. And so you're able to find it, access it, and utilize it all in one place. Okay, and that is ConnectAdvisor. It is included in OpenRoads Designer. And finally, just to sum everything up, we've covered quite a bit of ground, but I hope it's been useful to you. We've looked at designing with reality context, rapidly modeling design intent, integrating multiple disciplines, improving our project deliverables while adapting to change, and then finally producing or visualizing designs. Again, all of those issues or those critical business issues are part of OpenRoads Designer. So again, I hope you found it useful. Thank you for attending, and Bob, I think I'll turn it back over to you.
Okay, thank you, Joey. Well, we have just a few minutes left. I'll answer some of your questions that were submitted during the Joey's presentation. Change that. And you can also continue to submit questions using the Ask a Question box on the left side of the dashboard. Any questions that we don't have time to answer online will be answered in the archive of the webcast. You can check in there on our website later. So let's go to the first question. When will OpenRoads Designer be available?
Well, it is imminent. It will be available April the 1st.
So day after tomorrow.
Yes.
This question is for Mo. What advantages have you seen when it comes to designing in 3D? Did it add a great deal of cost or overhead?
That one's probably depends on who you talk to, but we've obviously seen over the years, there's some given things, identifying conflict, clashing and that type of stuff. I did have an experience where we also had an issue that the owner was not comfortable with one of the solutions, and the only way to prove that it would work was to do it in 3D. But really, probably the number one thing is with the construction industry. They want that data, and that is becoming more and more. Places like Utah, they're well into their pilots in working through the process, what needs to be delivered, how the contractor will use it. So those are some of the key things that we've seen. And like Joey mentioned, realistically, we've been modeling for a long time, but it's been doing modeling to produce 2D drawings. Now we're able to use the modeling for a lot more. So moving forward, and I know we're about out of time, so I'll stop babbling. So I'll leave it at that.
Okay. Next question. Can I use my files from Bentley's previous civil products like InRoads, Geopack, MW Road, or Power Civil? Joey, you want to take that?
Yes, you can. OpenRoads Designer will, you can open up and bring in ALGs, PIN files, GPKs, and so forth. So those can be used in OpenRoads Designer.
Okay, next question. Do you have a bidirectional link to Bentley OpenBridge Modeler?
OpenBridge, well, really OpenBridge Modeler as well as OpenRoads Designer are really, again, built on a common platform. We do exchange the geometry files and the terrains. So OpenBridge Modeler can utilize the designer's vertical geometry and horizontal geometry as well as the terrain models. So that data is exchangeable between the two products.
Okay, and a final question for today. Mo, can you give some examples of how DOTs are embracing the concept of SIM?
Absolutely. There's several DOTs that are currently going through. I mentioned Utah already. Utah is the one I mentioned during my presentation, where by 2020 they look to eliminate all 2D drawings in their process. That is they're probably being the most aggressive. But there's a lot of other DOTs. We last year did transformation sessions with Montana, Kansas. We've done work with Indiana. We're doing some work with Connecticut. So there's a lot of DOTs in the process of looking at. I was just in Nebraska as well, and they've already done, I can't remember the number, I want to say they've already done 14 projects where they've leveraged 3D data, and they have a lot more in the queue. And then you'll notice, I don't know if you're familiar with stick funding, but you can go on FHWA's site and just look at stick funding, and you'll notice that a lot of the DOTs, that stick funding is being used for this type of effort, whether it's 3D modeling or deconstruction, but it's all related to SIM.
Okay, great. Well, thanks. With that, we're going to finish up. And so you can please download your certificate of completion now from the Event Resources section on the left side of the screen. After downloading the certificate, you enter your name in it and print and save a copy of the PDF. Note that the certificate will be available only during the remainder of this webcast, so we need you to download that as soon as possible. A hard copy will not be mailed or emailed to you. If you missed our note at the beginning and you're watching the live webcast with a group on one person's computer, please download the multiple viewer registration form and complete and submit the form to receive credit. We need this information in case you're audited and we are contacted to verify this continuing education activity. Additionally, this webcast has been recorded and will be archived on csengineermag.com/continuing education. For viewers of archived webcasts, click on the quiz button on the event on the website to take a quiz on the presentation Archive viewers must pass a quiz in order to download the certificate of completion. Also, answers to all of the questions that were submitted today will be available online within a few days at csengineermag.com/continuing education. So please check there for further discussion about today's topic. As we conclude, you should see a webcast evaluation survey. We appreciate your feedback, which helps Zweig Group and sponsors such as Bentley plan future webcasts. So thank you to Mo and to Joey and to everyone who joined us. This ends today's webcast.